Hello, I'm Robert Hunt, inventor of the world's first successful free piston engine. The term free piston means that the engine's pistons are not connected to a crankshaft like conventional engines with which you are familiar. The concept has been around for over 20 years, and early free piston engine enthusiasts envisioned smaller, lighter weight engines that eliminated poor vector angles associated with crankshafts that lose much of the power produced by the engine's pistons, with greatly reduced frictional losses. Free piston engines would be far more powerful because the stroke length would not be confined by the rotation of a crankshaft. Vector angle analysis of a crankshaft indicates that almost half of the power generated by a piston is lost converting linear motion to rotary motion. Note that the rod of the crankshaft's best vector angle is less than 70 degrees, and only 470 pounds of 500 pounds of force, or 94% of the piston's power, is transferred. And then the vector angle progressively goes down from there to zero at top dead center position, at which time no power is generated at all. Then the rod's vector angle goes from zero back up to 70 degrees in a continuous cycle. The vector angle never achieves a perfect 90-degree vector angle. The net result of averaging the vector angle positions at every 10 degrees on the chart is that over 47% of the power is lost to poor vector angles even before figuring in weight and frictional losses associated with the crankshaft. While it is easy to realize the many possible advantages of the free piston engine, a means to control the engine's timing and stroke length has been extremely difficult to develop. And if an inefficient crankshaft isn't used, then how can linear motion be converted to rotary motion more efficiently? The following video taken during our test will help with your understanding. The free piston engine is being powered by 47 cubic feet per minute of compressed air at 95 psi, having an inlet temperature of 150 degrees F. Timing is accomplished by pressure changes produced by operation of the piston, using pneumatic shocks that compress a gas in order to stop the forward movement of the pistons, thereby controlling the stroke length. Additionally, the shocks provide energy storage via the pressurized gases that act like a spring to reverse the motion of the piston in the opposite direction. And a portion of the compressed air is used to activate the timing mechanism that controls the input and exhaust of compressed air working fluid that drives the main power output pistons. Note the smooth activation of our free piston engine. Linear motion is converted to rotary motion at an optimum 90-degree vector angle for maximum transfer of power via our revolutionary new Sprag gear transmission. An indexing Sprag gear catches in one direction, providing rotation of a shaft, then slips or overruns in the opposite direction, providing incremental rotation of the shaft in only one direction. Our novel Sprag gear transmission uses dual sets of rack and pinion gears in association with two Sprag gears that provide multiple shaft rotations during the outward stroke of the rack bar that is driven by the piston, and an additional multiple rotations of the shaft are gained on the inward stroke of the rack bar. And a perfect 90-degree vector angle is always maintained during its highly efficient operation. We set a goal of building a low-cost free piston engine that could produce efficiency on a par with turbine engines. These test results prove that we have accomplished that initial goal. The engine produced an efficiency of 70%. The air supply provides a theoretical power output of 37 kilowatts of power, and we were able to measure 26 kilowatts of power during these tests. This 70% efficiency is a record for an expansion piston engine. We have made a substantial breakthrough in engine design that achieves very significant improvements to engine power density, engine weight, and to engine mechanical efficiency with our first of its kind free piston engine. This same engine is capable of megawatts of power output, limited only by the pressure and volume of the input energy source. It is capable of operating on any pressure source, such as compressed air, the pressure of natural gas or water from the earth, hydrostatic pressure from a dam to produce hydroelectric power. Alternately, any heat source may be used to artificially create pressure to drive the free piston engine, such as geothermal heat, combustion of any fuel, solar heat, even nuclear power. The engine may be used for any application for which any other engine may be used, such as transportation, production of electricity. Tests will be used to aid in the design of operational improvements for future versions of the free piston engine that will help to optimize its performance.